Okay, let's continue our discussion regarding the circuit switching and packet switching. Circuit switching and packet switching supported for our data communication. Yesterday, we have seen a typical example associated with the circuit switching. A physical path is being established in the two subscribers. The two subscribers are utilizing the established path, and all data is sent to the same path. The advantage associated with this circuit switching is that entire bandwidth is available for the two subscribers, so that the duplex type of communication is possible for both the subscribers, and that data can be saved or sent without error or with minimum error. The error may be introduced due to the communication media in between the two subscribers. In case of packet switching, there is no physical path. A packet is simply a data that has been divided into smaller units along with the specified header. That header consists the information associated with the packet for ease of the transfer, so that the signal information can be communicated. Each packet contains the information that needs to be processed at the receiving end. Each packet follows a dynamic path or a dynamic route, not similar to the circuit switching. In case of circuit switching, the path is initially established, but in case of packet switching, the packet propagates towards the destination. The packet propagates towards the destination through any available path. It's not that a fixed path is, but the packet needs to be reassembled at the destination end. There is no uniform path that is followed end to end throughout the session, like the circuit switching. And that's why the packet switching is also known as a connectionless type of system. A connection is not at all necessary, as it can exist without one too. It needs to be present in the network. That's all. That's required for the packet switching. It is used mainly for the data transmission for all our data networks. For all our data networks, we are utilizing the packet switching. The packet amount of data that we need to send is divided into smaller number of packets. The packets consists of number of bits, since it's a digital communication, and this digital communication will follow the specified, not at all follow the specified path, as like in the circuit switching. In case of circuit switching, replace the two subscriber with the data terminals. The data terminals are connected to each other with a established path. That is the biggest advantage associated with the circuit switching, so that the entire bandwidth is available. In case of packet switching, the bandwidth, based on the bandwidth supported by the communication media in between the two data terminals, the size of the packet varies. The size of the packet is not at all a constant. It entirely depends on the bandwidth that is supported by the communication media. That's the difference in between the circuit switching and the packet switching. Due to the numerous advantages associated with the packet switching, we are utilizing packet switching for our data networking. See the specified pros and cons associated with the circuit switching. In case of circuit switching guaranteed throughput and latency. Once a path is established, your data is to be delivered towards the destination, and that is the biggest pros associated with the circuit switching. A single register is required instead of first in, first out type of buffers. But in case of the packet switching, we need to provide a specified buffer both at the sender's end as well as at the receiver's end. And that increases the hardware cost. This particular hardware cost is quite negligible whenever we are sending a huge amount of data. But and that is also one of the drawback associated with the packet switching, where the bandwidth becomes or a bandwidth is wasted when the traffic initial rate is lower than the channel rate. Channel, even if the channel is providing us the maximum bandwidth and we are sending a smaller amount of data, this is wastage associated with the bandwidth supported by the communication media. And that's one of the drawback for the packet switched network. But the parameters associated with the packet and circuit switching, efficiency, then bursty traffic, then address lookup and forwarding, then the packet switching, that are some of the constraints, or we can say the primitives that are associated with the packet switching. The entire packet switching for the data networking provides us the specified communication task. The first important communication task is the transmission system utilization. We have a specified communication media, we have a sender, we have a receiver. Sender is communicating with the communication media. Communication media is propagating the data towards the destination. At the destination end, the data or the packets are properly retrieved. But here, efficient utilization associated with the communication system is required, and that's typically one of the important parameter for all the data networks. The second important communication task is to interface the data properly to the communication media. If the system or the data is generated in an electrical format and you want to communicate that particular data through a optical fiber communication medium, which is a dielectric medium where the propagation or the data propagation is through the light, so that the proper interfacing of the electrical system with either the optical system, the electrical system with the electrical system, that is required. And that interfacing has given rise to the development of the modems, that has given rise to the development of communication equipments, that has given rise to the development of multiplexers to be utilized in the communication system. Whenever communication tasks are to be considered, the signal generation and synchronization. Now, here, all these parameters, signal generation, synchronization, exchange management, error detection and correction, are entirely the tasks that are associated, that defines quality of service associated with the digital communication system. The digital communication system property associated with the digital communication system helps us in properly maintaining the communication tasks for the data networks. Along with that, some of the important communication tasks that defines the error rate or that defines the data rate through the communication media are the flow control. The flow control defines according to the bandwidth supported by the communication media, according to the data rate that is processed at the sender's end, according to the data rate that is processed at the receiver's end. A proper flow control needs to be maintained. A proper flow control needs to be maintained, and that is one of the requirement. Another important communication task is addressing. The packets are divided into specified number of data frames or data packets. These packets are to be properly propagated, but the propagation path must know where these packets are to be delivered. So the address of senders as well as address of receiver is very important. and that gave rise to the important concept in the data networking, and that is addressing. There are different types of addresses, but the physical address, if you can provide it to an entity, then the packet can be properly delivered to that specified physical address. Then another important communication task is routing. How the packet gets routed through the communication media. And that has given rise to the various communication equipments such as network layer switch or the routers or the line modems, which actually provides us a proper route to the packets which are dumped into the communication network. The communication network not necessarily always will be a physical path, it may be a wired or a wireless type of path. Then another important concept associated or the task that is associated with the data network is recovery of the data. Whenever you are sending that particular data, and if that data is lost into the communication media at various positions, the data may be lost at the sender's end, the data may be lost at the interfacing end, at the front end, the data may be lost in the communication media. Whenever the data is lost into the communication media, that data must be recovered, and if that data is not at all recovered, that data needs to be retransmitted. And that gave rise to the reliable transmission of the data from one end to the another end. Then message formatting, which is again a very, very important communication task, message formatting. Whenever the sender is sending the message, the receiver must know what type of message is to be processed. And that's why formatting associated with the message helps the receiver to retrieve the information. Then nowadays we are adding security at every level. The security that is added at every level in the data networks helps us in defining and designing various security protocols. These security protocols helps us in properly providing the three different aspects associated with the security. Those are the data integrity, that whatever data you are transmitting from the sender's end must reach the destination end without any alteration. The data must be sent by authorized person, and data must be received by the authorized person, and authorized persons are only able to manipulate the data that is being propagated in the data networks. That is second concept. And confidentiality associated with the data. The data, we are propagating the data, the packets are propagated through the public network. The data must be received by the authenticated person who has the authorization over the entire data receiving process. Authentication, authorization, and integrity. These three important aspects associated with the security must be maintained as the communication task. And the overall network management. The system administrator must take care of the overall network management, both at the sender's end, at the interfacing end, that is the data interface with the communication media. So a lot of devices as well as a lot of software protocols were developed based on this network management. These are the important communication tasks that needs to be taken care of while designing the procedures or while defining the protocols in the data network. The two different configurations that can be utilized for the internet. Say for the internet network which we are utilizing in our entire campus, the computer department configuration which is connected to electronics department or electrical engineering department or mechanical engineering department. All these three networks are connected in a star type of configuration. The data must be properly propagated from the devices that are available in one department to the devices that are available in another department, which defines the configurations as the networks, the routers, and the host. The host not necessarily entirely be will be the computers. The host can be the computers, the laptops, the PDAs, or the network endpoints, which helps us in extending the data network. And whenever we are extending the entire data network, entire administration associated with that data network must be with the support of suitable network management system, and that's typically known as the enterprise data management system. Enterprise data management system manages the data in the entire networking format. Then that particular configuration is also well supported at the internet service providers end. And that's why internetworking as well as intra-networking plays an important role. How you define your network for your intranet and how your intranet is connected to the external network. These are the very important parameters whenever we are defining the protocols that are associated. See this different configuration. One particular network may be utilizing 802.3. 802.3 is the IEEE standards for exchanging the data. The various parameters of this 802.3, right from 802.3, 802.31, 32, 33. It consists of the IEEE standards for wired data network as well as wireless data network. Then one particular network may be utilizing the frame relay type of protocol, which is a suitable type of protocol to be utilized by wide area networks. That is typical example, the internet service providers providing the configuration to be allocated the data traveling or capability associated with the data networks, that is defined by the internet service providers. Then there may be one particular network which is utilizing asynchronous transformer. In digital communication, we have seen the synchronous type of data communication as well as asynchronous type of data communication. A huge amount of data can be translated with the support of asynchronous transfer mode. Whenever we are considering the internet, the there are different networks. So the addressing formats associated with the networks will be also entirely different. Then the bandwidth that is supported by every network may be again different, and based on the bandwidth latency of that particular network may be also different. Latency is the response to the data network request. Then according to the bandwidth supported by the communication media used for internet, the size of the packet, previously I just told you the packet size entirely depends on the bandwidth that is supported by the communication media. It's the optical fiber. If it's the communication media, huge amount of bandwidth is supported by the optical fiber. Whenever we are utilizing category 6 type of UTP cable, the bandwidth that is supported is almost around 100 Mbps. But the optical fiber as a communication media is able to communicate millions of TV channel. Each TV channel is having a bandwidth of almost 7 megahertz. So such millions of TV channels can be propagated whenever the backbone or the optical fiber is utilized in the data networks. Then how to translate the data and how to interoperate, and that plays very important role in defining the various protocols at the network layer, where the various devices such as routers, line modems are utilized, and the router management, the bandwidth management at the router, the attenuation management at the router, then the data disposal management, and providing the specified path to the hopped network. What is this hop network? We will see when we go for the practicals associated with the data network. But at present, remember that the various devices helps us in properly interfacing the different types of network. So internet service provider, network of internetworks, that is internet. There are almost 17,000 different internet service providers for the internet in the entire globe. and millions of hosts and new hosts in the form of passive nodes as well as active nodes due to the advent of internet of things are being added to the data networks. So the important design issues associated with the internet for sending the data from computer 1 to computer 2 with the support of internet. Computer 1 sends the data towards computer 2. Computer 2 acknowledges and sends the data required or requested by computer 1. So what is required here? The important design issues will be naming. This computer should be properly named. Then the computers connected to the internet must have a specified address and the specified type of routing supported for the packet switching network. The packet switching network helps us in providing a specified route to the packets, which are the data units separated or divided into number of packets from a huge amount of data. Each packet will travel with its own path towards destination depending on the bandwidth that is defined by the communication media used in the internet. And that's why routing is also one of the important design issues. Naming, the computers must be properly named. I can send a letter directly to the Prime Minister, Government of India, Aurangabad, because it's a unique name. It's a unique name, and the postal department knows where to send that letter because it's a prime minister. But that's not a thing. Whenever the common persons, there are a lot of people having the name Patil. So just by writing the name Patil, the packet data packet will not at all be delivered. I am talking just with a specified internet network, say for only Maharashtra. But there may be lots of parties, there may be lots of Doshis, Kulkarnis in the entire. They, on that particular specified name, the information cannot be properly delivered. That's why a specified naming constraints are always there, and that is the important internet design issue. The addresses must be properly defined. The addresses must be properly defined. Say the computer one. Computer one, what is the address for the specific site www.wisc.edu? This is a domain name. This domain name is translated to a specified IP address. This IP address for the domain name is defined by a specified sequence of the numbers. This specified sequence of the numbers is known as the IP addresses. That is a unique address. That is a unique physical, unique virtual address associated with the domain name. And with the help of this particular address, the packets from computer 1 will be exchanged with the local DNS server. The local DNS server will identify the next communication path for the specified data terminal connected towards the network of network, huge or billions. From the billions of the host terminals, a specified address needs to be find out. The path to the specified address needs to be properly defined, and then only the packet from computer 1 will be exchanged with the data that is being sent and received by the specified destination, say www.wisc.edu. It's a domain name that is translated into a specific address. The local DNS server translates this domain name. The domain name, what is this concept of domain name that we will be very easily identifying? But at present, just remember that google.com. Google.com is a domain name. This domain name is resolved into a specified IP address, which is a permanent virtual address associated with google.com. And that's why our requests are properly translated to the specified IP address. In the practicals, this particular concept of domain name and IP address will be quite clear. Then the last important issue is the routing. Router sends the packet towards the destination. The routers follows the specified path depending on the bandwidth that is defined by the communication medias in between the station 1 and station 2. In this particular case, this is the station 1. Station 1 wants to communicate with the station 2, or suppose this particular station 2 is a web server. So station 1 requests the data. The station 1 and station 2, in between there are various hosts as well as various routers. These routers are actually providing us the communication path or route to the specified packet. So this router will first of all communicate with this router. This router will communicate with in between router. If this router fails, then this router will communicate with another router. This another router, if has a communication path with this router, will have a communication path like this for one particular packet. Or for simplicity, we can define that suppose this particular bandwidth that is being supported by the communication media connecting these two routers, this router and this router, is say 10 Mbps, or for simplicity, we'll say 10 kbps. Then this router to this router, we have an optical fiber connectivity which supports the bandwidth of 1 Mbps. And this is again optical fiber which supports 1 Mbps. Whenever the packet from terminal 1 needs to be sent to the specified destination, the in-between router plays an important role. Now, if the huge amount of data is to be transmitted, if that particular data is to be divided based on the bandwidth, say 10 kbps or 100 kbps, the huge amount of data must be divided into the packets having the size of 100 kbps, and then the data can be propagated in this path. But if the bandwidth of this communication media is quite high, 1 Mbps, so the huge amount of data is divided into the packets of 1 megabits, and the route that is provided to the packets. That's how we are actually defining router to router communication, selection of the routers in between the data networks. Of course, we are going to study how actually router communicates with each other and how that destination address is properly formed and found out by the routers. But in between the two terminals, there are hosts as well as routers. The host are the data terminals. Routers are the data communication equipments. Routers, modems, all these devices are known as data communication equipments. Those propagates those packets from a specified sender to the destination. Sender and destination, the two words, or host 1 and host n. At the end, we are having the second host to which we want to communicate. Host 1 want to communicate. In between, there are various number of hosts as well as routers. And the packet reaching to the destination end is mainly due to the number of routers playing the interconnectivity part for providing the actual path for the packet. And that's a very key design issue for the network of networks, how the packets are to be propagated. That actually defines the quality of service, the performance guarantees. That is, whenever you are sending one packet or one file of say 10 Mbps, that 10 Mbps file should reach the destination end at a very faster rate. even if that 10 Mbps file is divided into number of packets, and all the packets may follow different routing path, but the reliability will be if and only if there is a very low corruption of the data, or there are no lost packets in the communication medium, so that the packets are not at all lost and the packets are guaranteed delivery to the destination. That actually provides us the development associated with a specified architecture for translating the data from one end to another end. This actually shows you what if the data gets corrupted. Whenever the subscriber 1 or terminal 1 or data terminal 1 wants the information having the file name index.html, but in internet that index.html, the name gets corrupted and the information that is being provided is get index.html, but index.html is not at all available on this configuration or on this server configuration. If it's the web server type of configuration, then if index or index.html is not at all available, this terminal knows, the client knows that this will provide us the information in the form of index.html. But if the data gets corrupted, then the information is not at all responsed from the destination end towards the source end. That's one of the data being corrupted into the communication medium. So in order to minimize it in case of our digital communication, we are adding the checksums. The checksums for the digital communication starts right from the parity check to the Hamming codes or utilization of the cyclic redundancy codes or checksum polynomial. We are utilizing same type of configuration in order to minimize the data corruption or in order to find out the data corruption in the data networks. So again, it's very important that we must know the digital communication format, the digital communication techniques, the digital communication synchronization, the bit synchronization, the properties associated with the digital communication techniques, so that the efficiency associated with the data communication systems can be enhanced. And that's the advantage that the electronics and telecommunication students, we know the digital communication. No other person knows the digital communication. Other branch persons, computer students are never studying digital communication, but the entire communication is a digital communication. All the data networks are the part of the digital communication system. And that is our added advantage. Electronics and telecommunication engineer knows all this. And that's why for all the network related jobs, first preference is always given to an electronics and telecommunication engineer who knows the concept associated with the data communication in lieu with the assignment of the data being a data in a digital communication form. That's where we have always a added advantage, electronics and telecommunication engineering. What if the data is lost? Terminal 1 or the client is requesting for the data, but the second terminal is not at all available, or the request from the terminal 1 is not at all reaching towards the destination. There may be various types of problems, but that indicates that the data is lost into the in between networks. Then the solution associated with this is, after a certain time duration, request again, re-request again retransmit again the request, and this procedure will follow till the response from the server is not at all obtained. So continuous persuasion is always done that gave rise to the specified or numerous protocols for the data communication, so that there will be a timing constraint, there will be a retransmission constraints, there may be the data that is lost into the communication media. If the data is lost into the communication media, retransmission of that data is only the solution. From the huge number of bits, if few bits even are corrupt, the entire packet is said to be a corrupt packet, and that entire packet needs to be retransmission unless and until there are certain mechanisms to recover only the lost bits into the digital communication format. But if the mechanism is not at all there, retransmission of entire chunk of the digital data is required, and according to that the data networks must retransmit that data in the communication network. We are dividing the data into number of packets. The packet is being reaching towards the destination end from the various routes. So there may be a data out of order type of problem. See the terminal 1. Terminal 1 is requesting in such a format: ml ind x.ht get. This will be processed in a reverse order. So get xht index ml, that is get x.ht index indeml. Whenever the get information is available, the web server will search for what is that particular packet that is being requested. If it's not at all finding that particular packet with the specified nomenclature, it will return an error. But this is the problem that is being associated as the data is out of order. The request is something different, and the response or searching at the destination end is something different. And for that, the solution in the data networks is to add a specified sequence number along with the packets. So the first packet that is being sent will have a sequence number 1. The third packet is available along with the first packet. If the second packet is lost, second packet is retransmitted, and then the fourth packet. But all these packets will have a specified sequence number. So at the destination end, according to the sequence number associated with the packet, the packets will be reassembled. So it will be get will be the first packet. So that get information is provided to the destination web server. Then second packet inde, then third packet x.ht, then fourth packet ml. So which will formulate a proper reassembly of the packets at the destination end. So the server will respond as get index.html. So all the problems that are associated with the data networking. If the data is lost, the data can be recovered or retransmitted. If the data is out of order, the data is sequenced, and as per the sequence number, the data will be retrieved at the destination. And this, I'm taking this particular concept before the development or the protocols that are actually utilized in the data communication. All the problems that are associated, if there are errors, the errors are checked with the specified digital communication error checking configurations. So to summarize what we have seen up till now, the networks or the functions that are implemented by the network are the links, then sharing of the links or sharing of the communication media or sharing of the various devices or multiplexing of the data, so that one particular data can be propagated to many devices. If the similar data is requested, then providing a specified route to the packets in the data network, then providing the addressing scheme or a naming nomenclature in the data network, then reliability of propagation of the packets, the reliability of propagation of the packets, then providing a proper flow control for the data that is to be propagated in the communication media, the proper fragmentation of the data. The fragmentation of the data will consist of the fragmentation at the source end with the need of the buffers, so that the specified number of packets will be buffered based on the bandwidth supported by the communication media. So the fragmentation as well as defragmentation required at the source end and at the destination end, that gave rise to the various protocols. Whenever we are defining the protocols, these protocols are the rules of communication over network. The rules of communication over a network. That means the rules at the sender's end, the rules at the interfacing end, the rules at the propagating end, that is the rules for propagation of the packets to the communication media, then the rules at the receiving end, and the sequence of the rules that are followed at the receiving end for retrieving the information. So whenever we are studying the networking protocols, the important why these protocols are required, then we will also study the open system interconnection model or a standard model, ISO OSI model. It's known as the ISO OSI model because it's suggested by International Standard Organization to utilize open system interconnection, OSI. System interconnection between the sender and the receiver. The standards are always open. Based on the standards, we can define our own strategies, our own procedures, and that gave basically rise to the design of the OSI model. The design of the OSI model basically that was suggested was actually the combination of the hardware as well as the software. So we can define the even the network as a combination of hardware and software that sends the data from one location to another location. The hardware consists of the physical equipments that carry signals from one point of the network to the other. The software consists of the instruction set that makes possible the services that we expect from the network, the services that are offered by the network. The networking task can be compared with solving of a mathematical problem. For solving a mathematical problem, we need to go stepwise. That is, suppose we want to calculate the efficiency that is associated with the system. It's a mathematical problem. For efficiency, we need to first of all divide how to calculate that efficiency into the number of steps. By defining these number of steps, any type of complex work can be converted into smaller tasks that are being involved, or smaller tasks that helps us in properly defining the sequences, the properly defining the procedures, and with the help of various mathematical tools that we are utilizing. The simple mathematical tools such as addition, multiplication, division, subtraction can be utilized along with the set theory, along with the mathematical theory, along with the various time series in order to properly approach to the solutions of a mathematical problem. These various steps in solving helps us in defining the specified layered task while approaching a problem or while defining the network protocol. We use this concept of layered configuration. This layered configuration, the rules specified for the network protocols. The network protocols, how the transmission media is physically set up, how bits are transmitted over the network. It's about digital communication. Remember, how do network entities know when to transmit the data or when to interface the data with the communication media? Then how the network entities know how much data to be transmitted based on the bandwidth that is supported, based on the capacity of the devices, networking devices that are used for interfacing. The network entities know how much amount of data is to be transmitted. Then the network entities actually also provides us the information about the recipients to whom the data or the message is to be passed. Then how do network entities contact each other? What will be the in between devices, networking devices, hardware devices, software configurations in between the two network entities, and the network entities which guarantees that the message is properly received and retrieved correctly by the other subscriber. So whatever may be the protocol, that protocol will be designed in need of all these rules. And for this, we are actually utilizing the concept of layers in all our daily lives. We are actually dividing all our problems into the smaller task and trying to achieve the solution associated with that problem. This processing of a later, okay, we'll consider this particular example. Let us consider two friends communicate through a postal mail. The process of sending a letter to a friend would be complex if there are no services that are available. One person is in Aurangabad, second person is in Karad. If there are no services available in between Aurangabad and Karad, the person from Karad cannot send a letter to the person from Aurangabad. But we have the institutions like post office. The post office actually helps us in providing the specified data transmission from one person at Karad to the data transmission to the another person at Aurangabad. The important task is to send the useful information. The useful information for this particular type of task is sending of a letter. But for this particular letter, we can define the sender can define the task into three different layers. The higher layer will consist of how the letter is written. The letter is written, how the letter is written. So the services that are required for written is the person must be a literate person so that he can write a letter. Then he must have the pen, he must have a paper. So these are the primitives that are the requirements for writing a letter. Then the person must have an envelope. So the person will write a letter, will put in an envelope and drop in a mailbox. But whenever the person is dropping the letter with an envelope in a mailbox, that envelope must have the address of the destination or address of the recipient. Then and then only the another layer, whenever the letter is posted in a mailbox, that letter will be identified, and by identifying the destination, the proper route will be provided to this letter. So in the middle layer, the letter will be carried from the mailbox to the post office. At the post office, there will be a sorting based on the addresses that are written on the envelope. So if it's the letter that is to be delivered to Aurangabad, the middle layer will carry the letter from mailbox to post office at the most post office, which is at a physical layer now, at a lower layer, will carry that particular letter with a proper communication media. That particular communication media may be a bus, that communication media may be a train, or it may be a airmail if the distance in the sender and receiver is quite large. But now Karad to Aurangabad buses are available. So post office persons will utilize the services that are offered by the communication media. The communication media here will be the bus, which will be carrying this particular letter from the sender to what's the destination at the receiving end. At the receiving end, again at the lower layer, we have the post office. The persons from the post office will sort out again the letters. Then, based on the address, the letter will be sorted and delivered to the persons that are available at the middle layer. The postman will carry this information to the mailbox of a receiver. At the receiving end, the reverse order will be there. Will the receiver will first of all receive the letter, receive the envelope, will open the envelope, and will read the message. The receiver can retrieve the information if receiver is a literate person. If receiver cannot read anything, he will just get the notification that the letter is available. But important information is not at all retrieved. So the requirement at the sender's end as well as the receiver end is that the sender and the receiver must be the literate so that the sender can write and the receiver can read whatever is written on the paper. Then only the information is said to be retrieved. Here we are defining three different layers. The three different layers are performing specified tasks at the sender's end. The same layers are performing reverse tasks at the receiver. And whenever we are defining the services, whenever we are defining the requirements, whenever we are defining the possibilities of communicating the information at the sender's end to the receiver's end and in the reverse manner at the receiver's end, the information is said to be communicated with the support of the tasks that are performed, the functions that are performed at the various layers. In the data networking, we are utilizing this particular concept. I think we will stop today. We'll continue same discussion of translation of the data and the layered architecture for the data networks. I will take the questions now from the participants. The participants, I am unmuting all. Let it be interactive. Anyone can communicate with me now. Any doubt? Gajanan, Rao Chaudhary, Gajanan, Anurag,
Hello.
any doubt, whatever we have seen up today. Nikita, Nikita Shivrai, Nikita, Sunande, Siddhi करता रहे.
No doubt, sir.
No doubt. Everything we have understood, that means. Abhishek is not again attentive. Runali, Somnath is not again attentive. If you are not able to communicate, you can post your question in the chat box. Not in the question answer section, but again in the chat box. of layered architecture for the data net. Amruta Patil, yes, Amruta, even if you are utilizing mobile, always use a headset, so that without echo you will be able to communicate with the faculty or even in the open platform. The platform is quite open. You can use Rupali,
No doubt, sir.
Sanika,
No, sir.
Swati Chauhan,
No doubt, sir.
no doubt. Muskan Mujawar,
No doubt, sir.
Asmita Chauhan,
No doubt, sir.
Shraddha,
No doubt, sir.
Payal.
No doubt, sir.
Yeah, we'll stop here. The next faculty is already in queue. We will continue tomorrow with the open system interconnection OSI model for our data net.